Hello guys, this is the last part of Windows anti-kernel architecture, and this video will be going through kernel mode drivers and hardware abstraction layer. Starting with hardware abstraction layer, this is a layer. This one is a layer between the physical hardware and the kernel and the rest of the operating system. Right? This one is kernel mode OS, and this is a layer between this one is the layer which which is extremely facing hardware. It was actually designed to hide differences in hardware and provide a consistent platform on which kernel is run. Differences as in each and as in embedded systems we have seen, you can see that there are several hardwares, right? For example, we have Bluetooth modules or Wi-Fi modules, Wi-Fi electronic modules, or any particular hardware circuit, hardware IC, which has its own each of these has their own firmwares. Firmwares are also OS for these particular simple hardware. Firmware are very low level OS to operate these hardwares by high level OS like in computing system, right? So these hardware abstraction layer directly interface with these firmwares, and they were used to hide differences, or actually OS programs itself will for the OS programs itself, the differences will create a lot of inconsistency. That's why this sort of hardware abstraction layer will give a common platform for all the hardware for all the firmwares, and execute their own corresponding code with some common platform. And this common platform itself is provided by HAL, hardware abstraction layer, right? In particular, hardware abstraction layer does not involve abstracting instruction set, which generally falls under wider concept of portability. It doesn't abstract instruction set for these firmwares, abstracting the instruction set when necessary, such as for handling the several revisions in x86 instruction set, or emulating a missing math coprocessor, is performed by kernel or via hardware virtualization. So we'll know that hardware virtualization is a bit different concept in itself. We'll not go deeper in that. Okay, so that's all for hardware abstraction layer. Now coming to kernel mode drivers. Kernel mode drivers, Windows NT uses these kernel mode drivers to interact with hardware devices, right? And each of the drivers, there are several drivers for specific hardware devices, and each of the drivers has well-defined system routines and internal routines that exports to the rest of the operating system, right? These drivers have some system routines and internal routines which is exposed to OS. Okay, now all the devices are seen by user mode code as a file object in IO manager. We can see whenever something is connected in our PC, right? In that file architecture, hierarchical file architecture, we can see a list of devices that in device manager itself, we can see in device manager we can see list of devices connected. There's one mouse, one Bluetooth mouse, or one gamepad, all those USB gamepad, all those devices, we can see the list. All the devices are seen by user mode code as a file object in IO manager. This can be seen as in IO manager. This can be done by IO manager. Even though the IO manager itself, it itself sees device as device objects, which is either file, device driver, device, or driver object. Okay, so these kernel mode drivers exist. There are three levels: highest level, intermediate level, and lowest level. Okay, the highest level drivers such as FAT, this is file allocation table, and NTFS for Windows, non-transferable file system, rely on intermediate drivers. Intermediate drivers consist of function drivers or main driver for a device. These consist of main Windows drivers that are optionally sandwiched between lower and higher. Yeah, and the function drivers then relies on a bus driver or a driver that services a bus controller, adapter, or a bridge, which can have an optional bus filter driver that sits itself between the function driver. So this is a bit complicated, but it can be imagined as let us not go that into that deep level. Let us consider that this particular intermediate level is main driver or functional or main driver for Windows, or it is also known as function drivers, right? And Windows driver model WDM exists in this intermediate layer, and the lowest drivers are either legacy Windows NT drivers that control a device directly, or can be a PNP hardware bus, legacy driver for Windows NT, or can be PNP hardware bus. These low-level drivers directly control hardware and do not rely on any other drivers. These are the levels which actually interact with hardware. These are the first level of interaction with hardware. So that's all for kernel drivers, and that completes our discussion with that completes our discussion of the complete kernel mode, as well as that completes our discussion for complete Windows NT kernel architecture. Okay, thank you for listening.